Well, keep me up today. So we're given this problem here. We've got our 2x squared minus 3x minus 5 over 2x squared minus 1x minus 10. Thank you, dear. What do we need to do to try and simplify this? Factor everything. So we're going to have to do a couple of these, and they're both kind of big ones. So let's get cracking. We've got our numerator. I'll do that one in purple. And I'll do my denominator in green, just because I like to make things color-coded so it's easy to see what's happening. Because I can see what's happening. You've got me in this musical mood now. So what? I'm just going to be like half singing everything. Because I can see what's happening. What? And they don't have a clue. They fall in love, but here's the button.
Oh, now I get
I was going to say, if you can't catch that Lion King reference, I'm just saying.
My brain hasn't processed that.
I can see what's happening should be enough to trigger that one in your brain. Just saying. Just saying. So let's take a look at our numerator here. Back on track. On the top up here, our A times C. What are we going to put up here? It's okay. Yeah, the negative 10. It's our 2 times negative 5. So we get a negative 10 up here. And on the bottom goes our B. That's a negative 3. I'm going to take that one. C is going, So we're looking for a pair of numbers that multiplies to make negative 10 and adds to make negative 3.
2 and negative 5.
2 and negative 5. What that means is when we're coming in here to our fraction, we're trying to write it in factored form. Can I go straight to my factored form right now? No, we have an A value up here, so we've got to use the full set of tools. We're going to do the full kit and caboodle whenever we have an A value. So we need to take our 2x squared from our original expression and our minus from minus 5 from our original expression. And then we get our 2x and our minus 5x. And then we pull our factors, columns and rows. What do we get when we pull those factors in columns and rows?
X.
1.
2x.
2x. And minus 5. So we get x plus 1 and 2x minus 5. Same thing with the bottom one. We got to do the same thing with our denominator. We take our A times C at the top. So this time, what are we going to have up here? Negative 20. And we get our negative 1 at the bottom. So in this one, we're looking for a pair of numbers that multiplies to make negative 20 and adds to make negative 1. 4 and negative 5. Good. So again, we have an A value of 2, so we got to do our full send box, where we take our 2x squared from our equation and our minus 10 from our equation, and we get our other pieces from those two values right here, our 4x and our minus 5x. What are we going to get, bless you, as we pull our factors, columns and rows?
X. 2. 2x.
Negative 5. So our factored form here is going to be our x plus 2 and 2x minus 5. Oh my goodness, we are trying to simplify this, so can we simplify? Because we have two pieces that are 100% identical, we can get rid of them, top and bottom. We can only cancel top versus bottom. So this simplifies down to be just what's left over, our x plus 1 over x plus 2.
Can we keep them in parentheses?
Yes, this is 100% the exact same thing as this. 100%. I think by the end of the week, you're going to be able to graph this thing.
Wait, what?
By the end of the week, you're going to be able to graph that.
Oh, yay.
Thanks.
What are these circle spiral things?
It's what Pre-Co's doing in their very next section. So they're gonna make, there will very soon be 10 more of them. End of next week. They're polar graphs is what they are. Those are graphs.
That's what I'm going to be doing in DC Pre-Co.
Like, see, there's the tables.
Oh, God. I'm scared.
To be fair, regular Pre-Co does it too. So. Alright. But let's get back to algebra. We already did that one. That's our parent function. So let's do this one. We're going to go to page 12. It says 11. It is, in fact, page 12.
Someone numbered these wrong.
Oh, on the slides? Could that be me? I numbered them wrong. It's me.
It kind of just looks like a scribble. I'm sorry, it's just my brain thinks it's a scribble. Thank you.
And then I lock it so that I can't, so we don't have to do it again next time. So I was like, and then I make it so that it doesn't erase when I erase everything to use this again for my next class. So we've got our transformation form up here. This is the guy we talked about yesterday where we decided how it was moving, all those things. So looking at our equation over here, our first job is going to be to figure out what our A, H, and K are. So what do we see? What are our A, H, and K? What do we think? K is -4. Absolutely right. A is 2. What is H? -3. It's always going to be the opposite sign of that little expression down here. Every single time. So that tells me it's going to move which direction with my H? Left. So we're going to go left 3. What's our K telling us? Down 4. And our A, what does an A of 2 mean? It's going to stretch. Yep, it's a vertical stretch. So those are our transformations. And from there, we can also get our asymptotes because our vertical asymptote is always, always, always going to be x equals, and it's always going to be x equals h. So it's going to be x equals -3. Our horizontal asymptote is always going to be a y equals. It's going to be a y equals, and it's going to be k, -4. So we're going to graph up those two asymptotes before we do anything else. So x is at -3 right here. So this is where we're getting our asymptote. And we do typically draw it with a dotted line. Yes, you have to draw them. You cannot skip them. Our y equals -4 is this guy down here. So that gives us a kind of view of what's happening here. We know it's going to be either here and here or up there and down there. and it's going to be some sort of loop-de-doop, like some sort of little L-looking curve thing. So the way we get all those in-between points is we need to make a table. So we're going to start with our parent table. We built this yesterday. Our parent function, that's our 1 over x. So our parent table is the one we built yesterday for that, where we had our x's that we used to find our y's. And we usually start with our -2, -1, 0, 1, and 2. And when we think about our 1 over x, that's 1 over -2, or -1/2. 1 over -1, which is -1. Our 0 is undefined. Then we'll have our 1 and our 1/2. We're not graphing that one. We just need to have the table, because that's how we use that's what we use to build our transformations. So to get our transformed function, what we're gonna do is get about 12 emails in the span of 4 seconds. My watch doesn't stop buzzing. Go away and hush your face.
What?
I said go away and hush your face. Talking to my watch, just to clarify. All right, so to get our transform function, we're going to take our x and add h, just like we have done for all our other transform functions this year. So we're going to take our x and add -3. So that's the same thing as x minus 3. Same thing with our y's. Remember how much the graphing makes us yak ya plus k. So we're going to take our y's times our a. We're going to go times 2 plus our k, which was -4. So we're going to go -4. So take all these x values and we're going to subtract 3. So -2 minus 3 gives us -5. And then -4. And then -3, -2. -1. And then our y's are where things get a little weird. So we're going to have our -1/2 times 2. And then -4. -1/2 times 2 is a -1. -1 minus 4 is -5. Then we're going to do our next one, our -1. -1 times 2 is -6. No, it's not. -1 times 2 is -2. -4 gives us -6. I was jumping ahead. In my head, I was thinking math and saying different math, and it didn't work right. The word undefined, I cannot multiply by 2 and then subtract 4, so it still remains undefined. I can't multiply a word. It's weird.
Has anyone ever tried?
I'm telling you from my grad school homework, yes. I have multiplied things that look like words. Just saying. Don't do that. You don't want to do that. Don't do that. Don't multiply words. All right. 1 times 2 and then -4. That gives us 2 minus 4, which is -2. 1/2 times 2 is 1. 1 minus 4 gives us a -3. It always feels like things are going weird in your table because it's bouncing from going up and going down. Like, it always feels really wrong. So then let's plot up those points and see what's happening. We've got our -5, -5, which is a point right here. And our -4, -6, which is this guy. -3 is undefined. That's our asymptote. Our asymptote should always wind up in the middle. Then we've got our -2, -2, and our -1, -3. So that's the information that we get, and we have to know how to connect this up. Our asymptote means it's going to hug that wall. It's going to get real close to it, but not cross. So it's gonna not cross the blue line, and it's gonna not cross the green line. It gets close, but not going through. We cannot Kool-Aid Man our way through. Yes, sir.
So do you think we should do different colors for each of the arrows?
You don't have to. I was gonna say, it might be easier if you do a different color between your asymptotes and your curves, but as far as what is easier for me to read, it does not matter to me. If you want to use a gabillion colors like I do, totally fine, and I've got a whole box of colored pencils, markers, highlighters, whatever. If you can do it all in pencil and get it right, it doesn't matter to me. But I am more than willing to read any number of colors that you have. So whatever works for you. So give it a try. Who knows? But that's what it's going to look like. Our last bit to talk about on this one is our domain and range. So we have two different ways of writing it. We've been doing a lot of interval notation this year, so I'm going to show it to you in interval notation. It's a little bit of a mess. So there is a shorter way to write it, and I'm going to show you that too. Because our domain here, since we have two chunks, it's going to look like two pieces. I'm going to have the domain for the left side of the asymptote and a domain for the right side of the asymptote. Same with the range. Same for the bottom side of the asymptote and the top range of the asymptote. So this left purple guy has a domain from negative infinity, and it stops increasing right at that -3. So our domain is going to be our negative infinity to -3, and then it jumps, and we are up at -3 to positive infinity for our right piece. The only thing it can't be is exactly on this line, which is why neither one of these have those square brackets. So you can either write it like this with our two intervals, which technically we join with a union back in our days of those. Or we can say it's every number that we can think of in the existence of the universe, all real numbers, except x cannot be our asymptote, cannot be -3. So this says all real numbers except x can't be -3. Both of these mean the same thing, 100%. And I'm good with either one. If you can write either one of those, I'm totally happy. Very, very similar for our range. It's going to be everything except where our asymptote is. Everything except -4. So we either are going to go from negative infinity to -4, where -4 is not included, and -4 to positive infinity. So that's our interval notation. Or, in our algebraic notation is what this is called, are all real numbers, except this time we have that y cannot be our asymptote, -4. The cannot be is just an equal sign with a cross out on it. Like, not equal to. Questions on this one? Okay. Let's look at the next one. Very similar vibe. We've got our g of x equals 1 over x minus 1 and then plus 3. What do we notice? Or what do we get? Our a is 1. Oop, that's not a pen. There we go. A is 1. H is 1. K is 3. What does that mean is happening transformations-wise?
It doesn't change vertically.
We neither stretch nor compress. It just is what it is.
But we do have a vertical shift of up 1 and, well, a horizontal shift of 1 and a vertical shift of up 3.
Up 3. And our horizontal shift of 1 is going to go which way? Right or left?
Right.
Right. So we're going to go up 3 and right 1. So that also lets us know our asymptotes. Our asymptotes happen right on those two values, our 3 and our 1. It's just that our vertical asymptote happens at our x equals. So we're going to have our x equals 1 as an asymptote. That's this guy. And at least these graphs have semi-decent grids, so we don't necessarily have to bust out a ruler to get a decent line. Mine's particularly trash this time. But, you know, it gets the vibe across. Our horizontal asymptote, that's when I get our y equals k. So we're going to have our y equals 3. So it's going to be this guy up here. We're going to need our parent function from the last one or from yesterday, either way, because that's what we use to make our transformations. It's the same exact parent table. It's still that 1 over x. So if you just like look at it up on the upper one, that's totally fine. If you want to rewrite it, I get that as well. Since I only have the one screen, I'm rewriting just so we can all see it. But you don't have to necessarily put this there, especially if you have another version on the screen. I figure we can also look. So let's do our transformations here. Taking our x plus our h, so x plus 1, and our y times a plus k. So our y values are going to be times 1 plus 3. And the rain has officially started.
It's so pretty.
What's up?
I color coded.
Love it. I'm happy that it's making you happy. So let's get our new points. So we're taking all our x values from our parent function and adding 1. So we're going to have our -2 plus 1. That gives us -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. So our y's here are probably the hardest bit because we're going to have fractioning stuff that stays fractioning. I do not care if you put things as fractions or if we put them as decimals. Does not matter to me. So if we take our -1/2 or -0.5 times 1 and then plus 3, that's the same thing as 3 minus 1/2. So it's 2.5 or 2.5. I have a tendency to go decimals or mixed numbers on graphing stuff simply because 2.5 or 2.5 is much easier to graph than 5/2. It's technically the same, but 5/2 is a lot harder to graph. So our -1 times 1 is -1, plus 3 is +2. Our undefined doesn't change. 1 times 1 is 1, plus 3 gives us 4. And 1/2 times 1 plus 3 gives us 3.5, or 3.5. So that gives us our points that we're going to plot up.
That's 4, right?
Here?
Yes.
Yes.
There's a mouse in the way. So.
Oh. Control that right now. Ow, I missed. There we go. All right, so let's plot our points. Our -1, 2.5 is there-ish. It's an estimate. It's an ish. And we have our 0, 2. Then we're going to have our 2, 4. And our 3, 3.5. So we're always getting these kind of 2 dots that are real close together. And we need to hug that asymptote. We can't Kool-Aid Man through it. We cannot cross them. And we need to make sure we run with an arrow. So our only option is to go down on the left one. And our only option is to go up on this one. We cannot cross the lines. So our last bit on here is to do our domain and range. Our domain, we could do it in the interval notation or we can do it in our algebraic notation. I think the algebraic is going to be the way we feel more like it because it's pretty much just grab the asymptotes. Because our domain is everything except our vertical asymptote. Everything except, so all real numbers. It's that R with the fanciness where it's got the double line on the R. Except X cannot be 1. So that's our domain. And our range is very similar. It's all real numbers. Everything I can get, every number on the number line, whether it is nice and polite and a whole number, or a fraction, or a square root of 3, or something gross and decimally, or pi. Yes, dear? Yes, I wrote your best, Miss Smith. And I was like, it could be pi, but it cannot be I. Like, we're doing only real numbers, no imaginary stuff. So our range is going to be everything except where our asymptote is, so y cannot equal 3. All right. Questions on this one? I want to do one more just so we can see one of those reflections from our A. So the next one has a negative A value, and I want us to see what that looks like. So take a look at number 3. It's on the next page. That'll be the last one we do. Because once we get the hang of these, they're not super long. Like, we can totally do them. The process on this is really the same. The hard part is finding our asymptotes. Really. That's kind of hard to get, I think. So let's look at number 3 real quick, just so that we can see those bits. And it's again off a page. It's page 13. So let's take a look in here. What is our A value? What's our H value? What's our K value? -3 is our A. So that means not only do we have a vertical stretch, it's also going to be reflected. This one's going to go upside down. It doesn't change what we do. We're just going to have to be careful. What's our H? -4. I like the universe frowned on that one. So what was our H? Thunder. What does that mean is going to happen? It's going to go left 4. Correct. And what's our K? -1. So it's going to go down. I'm yelling timber.
What?
I'm yelling timber.
Oh, okay. Brain had to think about
It's a little early, but that's okay. As I say, you've got me in this mood of musical mashups. So, the thing. So we're taking our same parent function that we did, our 1 over x, where we have our, say mowing the grass during a thunderstorm? That's intense.
I mean, it's technically not raining here yet.
I think it is. But I definitely heard what sounded like a lawnmower. It's still like dark. All right.
Let's stay on. Just kidding. I think.
What's up?
these are because we're in our.
Oh, yeah, no, that's not a thing I know. All right, so we've got our parent table. We're going to do our transformations. Same way we've done it before, our x plus h. So we're going to take our x plus our -4. So x minus 4. And we need our y times a plus k. So we're going to do our y values times -3 and then -1. These ones are going to be negative-y and decimal-y. And that's okay. We can do it. So our x is -4. That's a little easier to do because -2 minus 4 is -6. -1 minus 4 is -5. 0 minus 4 is -4. 1 minus 4 is -3. And 2 minus 4 is -2. So those guys aren't too bad. Then we need our -1/2 times -3. Ew. And then -1. It is a positive 1/2. Because -1/2 times -3 gives you 3/2. 3/2, which is 1 1/2, -1, we just get our positive 1/2. So you can either do it as 1/2 or you can put it as 0.5. I highly recommend typing these in the calculator because you look at it and then you question yourself severely.
I always question it.
Which is good and a wise choice, but it's also a little disconcerting when you do it for every single question. So if we do our -1 times -3, that one's a little easier to think about. -1 times -3 is positive 3. Positive 3 minus 1 gives us 2. And I still don't want to multiply a word, so we're going to keep our undefined. 1 times -3 is -3 minus 1 gives us -4. 1/2 times -3 gives us -3/2, which is the same thing as -1/2. So -1/2 minus 1 is -2/2. Which again, you can put it as a decimal or as a fraction. I genuinely do not care.
We didn't put the asymptote.
We did not put the asymptotes. We can graph it all in one go or we can graph it in bits. What are our asymptotes going to be? What's our vertical asymptote? Our x equals -4. And our horizontal asymptote? And it's y equals that -1. Gotta include those letters. It's really important because y equals -1 is an asymptote for us. And x equals -4. If we get them flipped, our asymptotes will wind up in weird places.
That's not -1, that's +1.
You are correct. Oop. And it's not going to let me move it. There we go. -1. Boom shakalaka. We love digital graphing. It's handy in that way. I could fix it. Way easier. Yep, so -1 and -4. Double check yourself because that would have been a problem. But I would have caught it in here because we would have had pieces on both sides of the line and that throws things off. So our -6, positive 1/2 is up here. There we go. Helps when looking in the right spots. And our -5, positive 2 is up here. -4 is our asymptote, so we're good there. -3, -4 is down here. And -2, -2.5 is right there. So this graph is going to wind up looking like this. It's very similar. It's just been flipped. And sometimes that throws us off. So I wanted to try one where we had that, where our right-hand side is not in the top right bit. It's in the bottom right. So our domain is, again, are all real numbers except for our asymptote. Our x can't be -4. And our range is everything except our y can't be our asymptote, -1. All right, so these aren't awful. I mean, they're not pleasant, but they're not awful. We've had worse things than this. So we can do this. Okay, so there's one more in your notes packet that you can do. I'm not gonna make you do it because we've got like 3 minutes till announcements. So you guys can now finish out that homework and do that so that we can get those graphs finished up. So yeah, do the thing. There's plenty of practice there for you. You can do the thing. Do the thing.